Okay, here's the problem statement. We've got this function, a rational function, and we're supposed to find the intervals on which it's increasing and decreasing, where it's concave up and concave down, the x-coordinates of the points of inflection. So let's actually work a little bit backwards on this. Here's the graph of that function, this red curve, and here are the derivatives. This is f prime, actually. And this is f double prime. And we'll find out how to get these formulas in a little bit. But the idea is to find where the function is increasing and decreasing. We want to know when the first derivative is equal to 0 or when it's undefined. Well, this denominator is defined everywhere, so there's not going to be any problems with that. But the numerator will equal 0 when x squared equals 11. So when x equals plus or minus the square root of 11, those are the critical numbers. And if we apply the first derivative test by putting those 2 points on a number line and finding out the sign of the first derivative in the intervals that are created, like if we put the number, negative 10 into the first derivative, we'll see that we'll get a negative number because this denominator is always positive. And if we put a negative 10 in here for x, we'll get a negative number. That tells us that the original function is decreasing. If I put like the number 0 in the first derivative, I get a positive number, so the original function is increasing. And likewise to the right of the square root of 11, like if I put a 10 in here, I'll get a negative number again. Okay, so that's what these points are right here. That's where the tangent lines are 0, have a slope of 0. And those are negative square root of 11 and positive square root of 11. And you can see this red curve is decreasing till it's that point. Then it turns around and increases, and then it's decreasing from then on. Okay. Now the second derivative, we want to know, when does this equal 0? Well, once again, the denominator is always positive, so it will only equal 0 when the numerator is 0. And here I've set it equal to 0, factored out at 2x, so that's at x equals 0, or x equals plus or minus the square root of 33. Same deal, we put those 3 hypercritical numbers on a number line, and the sign of the second derivative in each of these intervals will tell us the concavity. So for example, if you pick a number like, negative 10 again, to the left of negative square root of 33, if you picture putting negative 10 in to the second derivative, you will get a negative number, which tells us concave downward. Okay, I think negative equals a frown. And likewise, we get these other points of, the fact that the concavity changes tells us that these are the x-coordinates of the points of inflection. Okay, and finally, how do we find these derivatives? We apply the quotient rule. The first derivative is pretty straightforward. Denominator, derivative of the numerator, minus the numerator, times the derivative of the denominator, all over the denominator squared. This numerator simplifies into that minus x squared plus 11. Now the second derivative, still the quotient rule. Here's the denominator times the derivative of the numerator, minus the numerator times the derivative of this denominator. We got to apply the power rule followed by the chain rule. So here's the 2 moved out front, exponent reduced by 1, multiplied by the derivative of the inside. And now you might notice that on either side of this minus sign, there is a factor of x squared plus 11. So that's what this is out here. I factored out that x squared plus 11, and in these brackets, we find out the terms that remain. So we got a negative 2x times x squared plus 11 after we factor out one of these. After we factor out this factor, we've got negative 4x times negative x squared 11 plus 11. Distribute, notice that this x squared plus 11 in the numerator cancels out, so we get x cubed, and this simplifies to 2x cubed minus 66x all over x squared plus 11, the quantity cubed. Okay, there you go. Hope that helped. If you have any questions, post a comment.